Okay, so we are now live on YouTube. Hi, everyone. Welcome to ESMARConf2022 and this workshop on R functions and packages, an introduction to writing them. This workshop is being live streamed to YouTube and has a group of participants taking part live. A very warm welcome to you. If you're watching via YouTube and have a question for our presenter, please reply to their tweet in the ES Hackathon Twitter feed, and we'll try to reply to those as soon as possible. We'd also like to draw your attention to our code of conduct available on the ESMARConf website at esmarconf.github.io. Just for those of us joining on Zoom, if you do have a question, please feel free to raise your hand and I'll come to you, or pop it in the chat and I will ask it on your behalf to Martin. And just a reminder that because we're being live streamed to YouTube, if you do turn your microphone on or your video camera on, then you will appear on that live stream. With that in mind, I'll hand over to Martin Westgate from Atlas of Living Australia.
Lovely. Thank you, Chris. And hi, everyone. It's lovely to see you. I actually can't see any faces on the screen, and that's totally fine. We're here for the next hour and a half or 2 hours to hear about functions and packages. So hopefully that's a familiar concept to some of you. I'll dive in just a second. Before I do, I'd like to say that while I think a lot of you are calling in from Europe, I'm actually in a bedroom in Canberra right now in Australia. And that's actually on the land of the Ngunnawal people. And like to acknowledge that and pay my respects to the elders of the Ngunnawal people, past and present. A little bit about me. I lead a team called the Science and Decision Support Team at the Atlas of Living Australia, which is a biodiversity informatics facility that stores 100 million observations of plants and animals from around the country. And we do a bit of R programming as well. And that's what I'm here to talk to you about today. So I'm going to start sharing my screen in just a moment. Now, let's have a look. So I'm going to assume in going through this whole live stream that, well, for a start, I hope people can see my screen. I'm pretty sure that's the case. But also that you guys are fairly, at least a little familiar with R. And also I'm going to assume that you're using RStudio like I am here. So not actually my day-to-day development environment, but so, you know, if I have any hesitancy about using this, this screen, then that's probably what's going on. If I'm going too fast, if I'm going too slow, ask questions at any time. You can try and put them in the chat and I'll try and see them, or Chris might read them out on your behalf, potentially if I miss anything. So yeah, so I've got basically a workflow that we're going to go through here. And like I say, it assumes that you guys have done some work in R before and know roughly what a package is. And I don't think that's necessarily.
Oh, we seem to have lost you, Martin. Just bear with us. We're having some minor technical issues, and I'll see if I can get hold of Martin. Bear with me. Apologies for this. I will keep you updated as soon as I can. He seems to have disconnected. So just bear with us. I'm sure he will be back imminently.
Hi, everyone. You might have seen as it went dark in his video, he's just had a power cut. So I think he'll connect by mobile and get back very shortly. So just a couple of seconds. Thanks very much.
Can anyone see me now?
Yes. Welcome back, Martin.
Lovely. Sorry. Cut. We've got a storm in Canberra. Did not see that coming. So my apologies. I'm now sitting slightly more in the dark. If the power stays out, it's going to get slowly darker as I keep talking. We'll see how this goes. Okay. Where were we? My apologies. Yeah, so look. I'm going to assume that people have used packages before, and what I'm actually going to try and do is walk through a really basic example of building some functions in a package. And I'm going to lean really heavily on the automated tools that are built into RStudio. And the purpose here isn't to show what a full package will look like when finished. It's to give you guys a quick insight into the sort of steps that I follow and that my team follows in the workflows that we do for building packages at the ALA. So look, just for getting started, if any of you guys have RStudio open right now, all I've done, and I'm hoping this works. So I've hit the File button, I've hit a New Project, New Directory, and an R package. And that comes up with this little panel here. Now, this is all new in the last few years. When I started writing packages, you literally had to define your own file structure and things, but it's really quite straightforward. I've actually pre-run this, and I've created something that I've called nice plots. Typing in the dark. No. I'm not going to hit go again, partly because that would create two packages with the same name. Also because for some reason it crashed my RStudio. So I'm hoping that isn't the case for everyone. But once I reloaded RStudio, this had worked. And so what I'm going to show you is that once you've run that, is what you get. And basically, this gives you an empty file structure. I'll minimize some of the stuff that we're not going to use, with this content on the right in it. So to give some context here, not all of this is particularly important. We can ignore for now the rbuild ignore and the rhistory. Those aren't relevant to us. The really core parts are two folders, one called R. This contains, in this case, a script that's already open on the left. Doesn't actually do much. It's just a little function that says hello. And that's more to give a sense of what the structure of a package is, rather than because it's something particularly useful. Going back up in the file structure, there's another folder called man. I've never quite worked out why it's called that. We're going to kind of ignore that because that stores our help files, and we're going to build those automatically in a moment. So
I can actually answer that one, Martin. It's short for manual.
Oh, that makes sense. That makes perfect sense. Don't know why it's taken me about 12 years to learn that. Perhaps I should try and cover my lack of knowledge more carefully. The other thing you'll notice is that there's a .rproj file. So that is what I double clicked to open RStudio and to set this as my working directory. And that's a useful thing to have. I'm going to assume that once you've each loaded your package that you've reloaded from that rproj file. And then there's two things that are useful. Again, there's one of them is the namespace. We're going to ignore that because, again, that's going to be auto-built. In fact, we're going to delete this file in a minute and rebuild it automatically. The important one is the description. And at the moment, I've just literally typed the word nice plots, and that's all it's got. All the rest of this is boilerplate that ships with the package. But in practice, what this tells you is some little piece of information about that. Who wrote the package? There has to be a maintainer, and there has to be at least one author, and they can be the same person, and some little bit of text about what the package does. There is some content that becomes important later on, which is, I thought there was a suggests in here, but that's missing for now. It'll get built in later on, and depends. So those are fields that tell the package, and later on CRAN, if we want to submit it there, what other packages your package depends on. So I'm not going to write all this stuff in just now. It's enough to know that it exists, and that content is, I think, fairly self-explanatory. Obviously, before doing anything useful with the package, you populate that as a way of telling people what the package does. And for those of you familiar with CRAN, that information gets put on the web page there too for your package. So the important thing about a package, obviously, is that it contains functions. And those are a package is basically just a way of collecting a set of functions in one place so that you can reuse them. And I'm going to walk through a very simple example of what that might look like today. I'm literally going to just work on one or two functions. They're going to be extremely trivial in terms of what they actually do, but that will give hopefully an overview of what a function it looks like and how you use it properly, but also where it fits within a package. Now, normally at this sort of point, I'd stop and ask if anyone's got any questions, or if anyone's been able to run that, to load a new package themselves. Are there any questions from the group at this point about that?
So far, I've not seen any questions in the chat, but happy if anyone does have any to either ask them or pop it in the chat.
Yeah, I can stop at any time. So I'm happy to go back and explain details, or try running something on my machine if you guys are having particular problems. If you have code that doesn't work, drop it in the chat. We can see what we can get to do. So in practice, actually, I don't really want this function here. Someone's coming in with torches. That's very helpful. So I'll delete that in a minute. For now, I'm going to set a new, I'm going to start a new file. And I'm going to script. And then before I even get started, I'm going to save this into our folder. And I'm going to call this something like background color. May not be much of a giveaway to say at this point that we're going to do some example scripts that change visualizations in ggplot. Now, the sort of stuff that you want to put in a file like this are two things. It's the function itself and the information needed to build the documentation. Now, for the purpose of this exercise, I'm going to, I'll end up deleting some of this code, but just to show what the sort of thing we could do is with a function. So let's say we were to load ggplot2, and then we were to draw a plot. So I'm going to use the mtcars data set because it's built in and it's easy to use. I don't use this as an example data set very much, and I don't know what all these things mean. I just needed something that had two continuous axes on it. So let's have a look. What I'm hoping is that this will render in our plot window. So has that worked? No, it has not. There we go. Okay. So as you can see, a plot or a scatter plot, right? Nothing too complex, nothing too adventurous. Those of you who have used ggplot2 before will be familiar that you can build a plot in this way, where you specify some basic parameters, like I've done in that first line, assign it to an object, and then you can later on assign other stuff to it just by using the plus sign. So something that I have done before is set themes, for example. I quite like when I'm publishing work to do a black and white theme because it prints well. Something else you might want to do, though, is you can do all sorts of crazy stuff with theme. I'm going to do something hideous, which is to use panel background and set it to some horrible colors. Sorry if this offends your sensibilities. So it's very easy to do something like that, for example, when you get a red background. As may become clear, this is not necessarily a good idea, but it is possible. And for those who really want some a lot of options, the help file for theme lists everything that you could possibly do in here. Now, I think this is long-winded, but it is really comprehensive and really useful. It's possible that you want your backgrounds to be read so often that it's worth you building new functionality just to do that without you having to go back to the documentation every time. And so what we're going to do now is build an example function where we do that. And so if we were to say something like background color and name that as a function, way we do that is we literally just define it as an object. We could use the equal sign, but the sort of left arrow is a bit more accepted. And we literally just type the word function. Now, if we always wanted this to have the same effect, if it was always going to be red, we could do something like this, where we go. We simply copy this text that we've already written and just put it in a new function. So just to show what that does, I'm just going to load that into the workspace. And we've still got our plot from earlier on. In theory, now we can go P plus background color. So just to give, again, it is hideous. I understand that. All we've done is wrap the generic function theme, which has lots and lots of options, into something a bit more specific that we actually want to use. And you could extend this downwards. You could say, actually, I want the panel background to be red, but I want the lines to be green. A more useful thing to do is to define arguments. So at the moment, this function, the things you can tell this function to do are effectively nothing. You just by having opening and closed brackets, you see that it is a function and rather than just a named object in the workspace. So R knows that it's a function, knows to call it as one, but there's nothing you can tell it to do. You can't change its behavior. You either use it or you don't. Obviously, that's not a common or necessarily useful way for a function to behave. Something a bit more common is for you to say, actually, I want to be able to specify the color for myself. I'm going to use American spelling because there's fewer characters. Hope that's okay with everyone. In which case, you can then literally just pass those around within the function and R will do the thinking for you. So you could literally say, I want the color to go here. So if we reload that now, actually this should fail. Now that I think about it, yeah, you get an error because you haven't told it anything. But if you give it some text, it's not nicer, but it is more customizable. And I think in theory, you could actually set this to be like, oh gosh. Let's see. I don't know hex codes off the top of my head. Oh, dark gray. Horrible. But anything that is interpretable by R as a color could get passed to that. You could also, if you were being very clever, say, set a default. There's two ways you could do that. You could say in the function itself, you could define something. So let's load that again. Now, if we delete this text, remember before this errored out. Now it chooses red by default, but it can still be overwritten. So that's useful. Alternatively, we can do something like, we can tell what we want it to do if it's given no information. So we start with an if, and then there's a particular function that you won't have used necessarily unless you build functions, because it doesn't really work in a reactive context, but it's called missing. Ooh. So I'm using a new ergonomic keyboard and I'm not very good with it. So that should read fairly clearly. If we're missing color, that is if no one has entered a value, then we tell it what our default should be. And it should have the same effect. So again, let's load that into Workspace. There's no value, it's yellow. We tell it there is one, it goes green. Hopefully that's fairly clear. So feel free while I'm doing this to be testing your own functions. Like I mentioned, theme has many possible options. You could set your grid lines, you could set your fonts, you could set your the size of your text, anything you want. With this sort of a format, obviously you wouldn't call it background color in every case. Some of you may have noticed that this is a little bit repetitive, right? So we have, each time I've run this, we've had to copy this bit of text and put it into the workspace, into the console, I should say. it should be fairly obvious that if we had 5 functions or 10 functions or 100 functions, that would get very cumbersome. And that's the point of a package, and it's the point of the set of workflows that we're going to talk through next, is to say, how do we start doing this in a more efficient way? This is useful for like iterating on getting something right, but how do we make that work more efficiently? Before we get to that, I'm going to assume that this is a sensible example function. There's an extra thing that you can put in these files that makes them much more useful for a package development workflow, and it's Rcmd. So Rcmd2 is the name of the package that we use for documentation in our packages. There are other ways. You can handwrite your own documentation. It works. It's fine. I've done it before. It's a little slow. The benefit of putting your documentation straight above your function is that they're right next to each other, and it's easier to spot errors. Plus, you can get that. This is a bit. Rcmd is generally a bit easier to write than ours default markdown for manual files. So basically, the way this works is you give it a title. You say, which should say something about what the function does. Set background color in ggplot2. You'll notice that because we're using RStudio and it's been set to recognize this sort of Rcmd format, is now putting in my insets for me. So there's this sort of hash followed by an apostrophe is written in, so I don't have to keep typing those 2 characters followed by a space. But the format for Rcmd is that you have that title, then you have a skipped row, then you have your description. This makes, whoop, is that working? Don't know what happened there. Okay, this makes can't spell. Beautiful plots. And then I think for now, the only thing that's really important that we're able to do is tell R that we want this function to be available to the user. Hit the word export with an @ in front of it. And delete any code that isn't part of the function. So that's very minimalist, but it should function, as in it should work.
Martin, Tanya from the UK has just asked, how do you get the automatic little £sign with the quote mark after it to appear?
£sign with the quote mark after.
You know, the starting thing for the Rcmd comments. It looked like when you made a new line, a new one appeared automatically.
Yeah, look, and I've literally learned that today. Because like I say, this isn't my usual development environment. I hand typed that first one. So that's literally a hashtag and then a single apostrophe. And then after that, I'm just hitting enter and it's doing it for me. Ironically, deleting them is a bit slower. So does that make sense?
Yeah. Yeah. She said, okay, thanks.
Yeah, I like I say, learned it today. A useful feature. Apparently those guys at RStudio definitely know what they're doing. So just to show where we're at then, we now have 2 files in here. I'm going to delete this hello one because that's just for example purposes. Yes, I'm going to delete that. And actually, just while we're at it, I'm going to do the same in the manual file because we don't need this anymore. So we actually have less in this package than we did when we started. Oh, and one last thing I'm going to do, this namespace doesn't contain anything at the moment, really. It doesn't really matter what that means, but it's useful, but it's not terribly useful. When we use Rcmd, we're going to do some stuff that builds a namespace file for us automatically. So I'm just going to delete that for now, and it will repopulate it in a minute. Right. So this is where we come into how a workflow for actually building and testing our package itself. So until now, we've been playing around with ggplot. There's a few base functions that we've looked at. we've generated some plots, we've used mtcars, some data, but it's all just been to get that plot, that single plot to work in a single instance. When we're doing operations on the package itself, there's a new package that we'll need, which is called DevTools. So obviously, if you don't have this already, the function is install.packages and then quotation DevTools. It's already installed on my system, so I'm not going to actually hit go on that. So I'm just going to load it. Now, DevTools, actually, I'm just going to launch this for a second, launch the help file for it. Assuming you've done things like load from a .rproj file, there's not much in DevTools. This is their whole help file. There's not much in it. That's a very misleading phrase. There are not that many functions for something that is this useful. It does have a lot of dependencies, so it builds on a lot of underlying work, but it's actually a very clean package to use. And actually, what might not be entirely clear from here is that the things you use all the time are just a single word. They're things like check, build, create. Oh, I should have used create first. I forgot about that one. And in practice, we're only going to use 2 or 3 of these very much. The first one we're going to do is called document. I'm just going to hit go. Oh, now this is giving us an error because I've already, basically what it's telling me here is that within the package niceplots, which I've just built, there's a function called background color, and that already exists in the workspace. Of course it does, because we put it there when we were testing it. So just to stop that error coming up, it might make sense to delete this stuff. And actually, a fairly sensible thing to do is to simply cycle your whole workspace. So you can do something like restart R. That should mean that the whole workspace is clear now. Oh, no. No, I must have saved it somewhere. Never mind. Scrap that. Yeah. So we'll remove this for now. And we'll try that document again. I've got to load DevTools again because I reloaded R, and so my libraries aren't the same as they were. Document. Okay, so you notice that's done a few things. It's given us an update. Basically, it says, okay, we've checked your documentation and updated it. The main thing we've done is written something called a namespace file. You remember we deleted that before. If we open it now, it says this, it has this export background color. So you'll recognize that as the name of the function we defined. And you'll notice this is the same tag as is written in our file on it. It's just here. Export means that your function you've written is available for users. That might sound trivial. Of course, you want people to be able to use the functions you've written, but in practice, I don't know how much this is true for everyone, but in the packages that I've written, I've always needed internal functions. That is, things that do useful things, but that you don't want everyone to see. And it's not just because they're messy, they can be. They could be perfectly and beautifully written. It's just that you want the user to have as clean a set of functions as possible. And so often that has the effect of hiding some of the more complex functionality from the user, and it just seems to work seamlessly in the functions that you use. So actually, this export is not given. You won't use that in every case. So where are we at? So we're basically at the point now where the namespace says that this function should be available to the user, and that function has been defined by this set of code. And that's the whole package. That's all it does. And just to test it, we can now want to check that it actually works. Normally you'd use library, right? Like we did for DevTools. I really doubt this will work. It certainly shouldn't. Okay, that should have failed. I don't know what it's actually loaded, but what you should actually be using rather than library to avoid confusion. And the reason I raise this is because it's possible that there is an actual package called niceplots that someone clever has written rather than this really small toy example. in which case running library is a mistake. What you want to make sure is that you're loading your local one. And the function for that is in DevTools as well. It's called load all. And again, because it's just choosing your working directory as a package and setting that up, you don't need to give it any arguments. You just go load all, and you'll notice that's come up nicely.
Hi, Martin. Sorry, someone's just asked, would you recommend one function per .r file, or how would you recommend laying out your package?
I like one per exported function. So that's another point that comes up here. So it's possible that, for example, background color would need functions inside it that are useful to me, but no one else. And it's also possible that those functions are only used by background color and not by other exported functions, in which case it's possible to write things, oh gosh, I don't know. What would this even be? Say if you wanted to do something like choose default color. This is terrible behavior. Never write something like this for real. But you could do something like sysdate. Let's do that. So I don't know if people use this as one of the base functions. You could say if there is 3 in sysdate, then, so that's a fairly complicated if statement, but it works. Then maybe the default color is yellow, but otherwise it's red. Again, an insane function to write, not something that anyone would do, but you could put that here. And that'll still work. It's just the default will change depending on where in the month you are and what year it is and a whole bunch of strange things. Let's assume that I'd written something sensible rather than something crazy here. That is a sensible thing to put underneath this function. It's not exported, but it only relates to this one. There is another situation, which is where you have sort of functions that are really critical infrastructure to the whole package, but are still hidden from the users. So they appear in lots of different places, and they should tend to get their own .r file, even if they're not seen by the user. That's my policy. I think other people would have different ones. It depends a little bit.
I tend to group my functions by sort of theme. So stuff that's related to setting the background color would go in one file, but stuff that's related to setting, say, the grid line colors would go in another, for example.
Yeah. Well, and the way that you could do things like that is you can put more than one set of oxygen stuff in a single file, and it works the same way.
And Valentina has just asked, how did you choose that only background color is exported and not choose default color since it's the same file?
So how is only this function exported and not this one?
Yeah.
It's what comes immediately after this export tag. So we can do the same again. Hang on. We could So in this case, I'm not going to do anything here, but in that case, these 2 functions would be exported, but not this one. You can get really specific and say, actually, you can name it. Background color. I haven't tried this and it feels a little risky, but you could, in theory, just put all your exports on one line. I suspect that would work. But actually the coloring of that tells me that maybe it wouldn't. Not sure. Safest way is to have one export, one set of oxygen documentation per function and have export at the end.
Thanks, Martin.
Yeah, okay. I think that's, I'm actually going to delete this for a second because I'll probably make a mistake and I don't want to confuse myself. So I'm going to save that file. And then what I'm going to do, I'm going to assume that I haven't changed the documentation enough for that to be an error, and I'm going to load all again. So now the ultimate check is to say, does this function still work? Let's have a look. So we'll type in our same plot code as we did before. Background, and actually, no, let's just run that first. Could not function. Now, I did actually write a note to myself to do this on purpose. So I'm going to pretend that I did do that on purpose. What you'll notice, though, is that it isn't able to find where these functions come from, right? So, oh no, I haven't called anything yet. In this case, what I'm going to do is call, in the right place. So I hadn't loaded ggplot2. Let's try that again. That's worked. And then background color. Worked. Great. And actually we'd expect it to be red because there's no 3 in the date at the moment. So, sorry, such a dumb example. So that is actually, while aesthetically displeasing, from a package development perspective, is the result we had expected. What I think would be interesting now, though, is that we're fooling ourselves into thinking this would work because we actually haven't told the package that ggplot2 exists. You notice we've called these different, several of these functions. So we need ggplot to make any of it work, but theme is within ggplot2, and so is this function element rect. So in practice, any user that was going to use this and didn't load ggplot2 would fail to be able to use it. And that's where our description file comes in. So I mentioned before that there's some actually really important stuff that goes in here that's currently not there. And those are depends. And actually there's another one which is suggests. I'm going to put depends in. So basically what we do is we tell our users and the system that we need ggplot2 or none of this stuff will work. And that's self-evidently true because this these functions are from ggplot2. Another, to be even more certain that we can get this function to work without the user having to think too much about that, we can tell it one of two things. We can either say import all of ggplot2. That works. It's not particularly tidy in the sense that there's a lot of stuff in ggplot2 and we don't use all of it. To import a whole extra package to do two things is a little inelegant. You could ignore that completely, just have the depends, and every time a function comes up, you can specify the package that each function comes from, like this. As long as ggplot2 is in depends, that should work without this import. I'm told that in practice, the delay that introduces is like 5 milliseconds. I don't really know how much I should care about that, but that sounds like a delay, so I'm not going to do it that way. So the last option is you say, actually, rather than just import the whole package, I'm going to tell you specifically what I want from there. I want the function theme, I want the function element rect, and I want nothing else. So this is a way of, you still have to install ggplot2 for this to work, but for your package to work, it's only pulling out a few of the functions from it. So it's a little bit neater. So a lot of detail there, but all just to basically let this package know where it's getting its information from. The only reason you ever really need to do more than that, this is useful for the developer as well for a start. So it tells you where you're getting your information from. If theme was used by 6 different packages, sorry, the name theme was used by 6 different packages for different functions, you've still got a potential ambiguity here, in which case you might add the ggplot2 element back in. That's a very rare instance. I can't think of, I can think of places where the same function might be used by 2 packages. It's not common to develop with both of them at once, but it could happen. But it's rare that a function name is used many, many times. So we're now confident that this package will load. Before I go on to talk, so the next thing I'm going to talk about is testing. And to me, testing and documentation are 2 sides of the same coin. That I used to dislike them. I come from an ecology background. I didn't train as a computer programmer. If any of you have trained as computer programmers, this will seem outstandingly basic to you. The CRAN package ecosystem doesn't require you to write your own tests to get things on CRAN. And many developers have pointed out that because of that, it actively disincentivizes testing of your package, because they run tests as well, your tests on your package on their system. And so if those tests fail, they can archive your package. If you have no tests, it gets past that problem. But it means your code is probably wrong at some times, you won't know. The more package development I've done, I came to good documentation first, because I found I can remember how to use the functions that I'd written, even though I'd spent a lot of time in them, and that feels wasteful. And then as a logical extension to that, tests in bits of software that check that things work the way they should. And so they embody decisions that you've made about the functionality of your package and its behavior. And what I've come to notice, and by far the first person to do this, and in fact the reason tests exist, is that you forget the decisions you made on your package a long time ago. And so it's very easy, particularly as the number of functions and the number of lines of codes increases, it's very easy for you to break some bits of your package without even noticing. And a test is designed to catch that situation, where some great idea you've had that changes a set of functionality mistakenly breaks a whole other set of functions you weren't looking at, and it prevents you inflicting that challenge on your users.
Sorry, Martin, just going back just very quickly to the import from stuff. Neil's asked, I find it difficult sometimes to remember which packages my code depends on if I don't use package colon function. Is it best to update import from every time a new dependency is added, or is there a way to find dependencies in a function you've written without package colon function?
Yeah, so that is a good point. So I have come to use import from for that same purpose, to remember, and so that is to say, I use it to remind myself what I'm depending on. Because at a certain point in a package development process, I'm not sure if everyone does this. I think it's not terrible practice. I have another look back over my dependencies and try and make a decision as to whether they're actually being useful or not. And it's surprising how often you import a package to use one function and then realize there are 6 other ways to achieve that without relying on that dependency. So my process is that I put it at the top here, and I write this as I'm writing the functions, because I can't remember afterwards. And then when you build document, actually, let's run that now. I'll make sure this is saved first. Save that. Can't even type it. Okay, see how it's been writing namespace. If we click to that now, that's written in there. So the namespace acts as a lookup to everything that's getting imported. And I'm trying to remember, I think that ends up being alphabetical. It might not be. It might be in some obscure order. But I think it's alphabetical. And in practice, what it means is, because this is automatically generated, but description isn't, it's actually possible, and I've done this myself, to write things into depends that you later delete, and they get removed from namespace automatically, but not from depends. And so your R doesn't know what to do with that. It doesn't know that that's wrong. So it continues to think it's depending on things. It imports those packages when you install it, but never does anything with them. And so actually using namespace to like check back against the description and index one against the other is a useful way to see if your dependencies are right. Neil is flat out right that being really specific about this comes from ggplot2, but I don't know what, say this came from somewhere else. Is a more visual way of seeing every line by line what you're relying on. So to some extent it's what helps you. To some extent it's style. It like I say, there's the documentation I've read, I've never benchmarked it myself, is that there's a slight slowdown from adding the package name, but on a scale that most people won't notice. So that's my approach. I think others are just as valid. Oh, and actually, just looking in the chat, Neil's right that things like AES are also functions. That is actually another benefit, specifically for plotting stuff, is that ggplot has more functions than you'd think. Like if you look at this example we just wrote, that's 3 functions right there. ggplot, AES, GOnPoints. Yeah, almost as many functions as there are other things. And that's intentional, right? Like that's the way that a package has been built, is to be fairly modular and to have functions that, like GOnPoint, you can specify arguments, but you don't have to. It still does something kind of nice. So you kind of forget that they're functions. And so if you're trying to mark each one of them in terms of the package it's from, it just takes time. It's a lot of repeated text as well, which we're often trying to avoid in writing packages.
Martin, sorry, I've just had another question come in via email. So someone's just watching on YouTube and they say it's a brilliant conference. They just had a quick question. So this person has a Shiny app that uses 5 or so quite long functions they've written themselves. Will the Shiny app itself load faster if those functions are sort of removed from the app itself and put into a package that's then loaded from the Shiny app rather than having the functions written out directly inside the app?
Ooh, good question. I'd expect so. You could benchmark it fairly easily, right? Like you could test both of them just by copying your file and doing each of them. So there's actually, just while we're on the topic then, so the micro benchmark package is what I use for this. It is for really fine scale differences. So it makes sense to do like for testing, small functions. And because it by default runs 100 replications. If you're, testing loading times on a Shiny app, you'll be there a few seconds. So you can change the number of times it runs. The way this basically works is I'm not going to run anything too much now, but you say, you give it many functions inside it. So so you put things within curly brackets and say, well, what's the performance difference? See what that does. Whoa. That's accurate nanoseconds time to avoid. Okay, I don't know what that is. So yeah, you can get it to run sets of code within curly brackets. And this is how I tend to use it. In practice, it's usually fairly obvious which the quicker of two solutions is going to be, or you can't think of another way to do something anyway, so it doesn't matter how fast it is. So it's not always necessary to micro benchmark things. For that Shiny app example, I'd expect putting in a package is one solution. There's also an option. It's been a few weeks since I've done a Shiny app, but you can put things in an R folder in there, and I think it uses source to load that. SOURCE, that is. And I suspect that would be faster than just literally putting all your functions within a single script like app or. Oh no, Shiny apps are single files these days, aren't they? I'm remembering them from when they used to be two, when you used to have your UI and your app separately. I would think that putting them in a separate R folder and loading them would be quicker, but it's largely a guess, and something like microbenchmark might be able to help you answer that. So
cool. Thank you very much.
Yeah, no worries. Yeah, and it's funny actually, I deliberately didn't put anything on Shiny in here, partly because it's hard to keep current because it moves quite fast, and it's but it's just hard code, right? Like maybe in a future session we'll do something on Shiny apps. They are increasingly useful, but also difficult code in some ways. Right, anyway, getting back to this, where were we at? Last thing I did was, so look, the last thing that's useful to do once you've done so the last thing I did was document and then load all. So you load that package back in. And then the obvious thing to do is we ran a test to make sure that the function works, is to look at whether your help has rendered properly. Oh, didn't spell it right. And the benefit of DevTools is that if you're using RStudio, it looks identical to what an actual help file would look like. If you're using the R console that ships from CRAN, this will just load in a browser, so it's still useful. Obviously, this is very minimalist instructions, but you can see that you've written some help information there, and it's simply been rendered out of this commented code here. And actually, it's added things that you wouldn't. It's recognized that this is a description without you having to tell it, for example, as well. It's recognized this is a title without you having to tell it. So it's done some fairly clever things. It also gives you the name of the function and the name of the package that it's within. If we wanted to go the whole hog and test what this looked like when you actually install it, you could put this on GitHub and install it from GitHub, and then you'd get an index at the bottom here where you could flick between functions from a single package. So that can be useful to do when you're a bit more advanced than we are in this case. But we were going to move on to testing next. So yeah, I was just saying before that documentation to me is really helpful to remind myself what arguments something needs. So actually something that is critical to documentation that I've completely missed here is, oh gosh, what's it called? Sorry, I've got my notes here and I'm completely gone blank. So there's a name, no, it's not one of those. Parameters, should remember that. So this is the bit that the user is actually going to need. And by user, I mean you in about an hour's time when you've forgotten what you've written. So usually the format here is you say the first parameter we've got is color, and then you tell yourself something about it. This has to be a string that can be interpreted as a color, e.g. a hex code, whatever. It's surprising how often I forget to do this and come back and go, well, what is color supposed to be? Is it a matrix? Is it a data frame? Is it a string? Can it be a factor? You know, like these are, it sounds dumb, but it's really, really easy to do. And so having that information in there makes it much more straightforward. It is, of course, critical for CRAN. So if you ever want to put your package on CRAN, you have to document this stuff as well. But just to show, so I'm going to keep doing the same workflow just to show that this, I literally do this every time. Document to build your documentation, load all to make sure it's in your workspace, and then you can check your
Martin, sorry, we've just had a question from YouTube. So what's the difference between depends and imports in the description file?
Right. Yeah, there's three, aren't there? There's depends, imports, and suggests. So the two I use most are depends and suggests. Depends are things you have to have or the whole thing doesn't work. Suggests are things that, now I use suggests. Generically, what it means is they're useful. Specifically, what it means is that you use them in some of your testing or your documentation. So it comes up a lot when you use vignettes. Imports. I forget the difference between imports and depends. There is one I've looked at before and gone, that's clever, but I can't remember what it is. So yeah, I'd go look up Hadley's book for that because he's better at this stuff than me. Sorry to not be more help, but I simply cannot remember. Yeah, sorry everyone. So yeah, just say that then that that document load all workflow is something we'll come back to all the time. In practice, you can use the up button to literally just load the previous bit of code you did. And I end up, my workflow ends up when I'm, particularly with documentation, I'll see a typo something isn't as informative as it could be. So for example, say here that this has to have length 1. And then what I'll do in the workspace is I'll literally just use the up button on my keyboard until I get to go back through previous functions, run document again, run load all again, check the documentation. And you notice that that's been updated there. Now that might sound inefficient, and for something small like that, it's trivial. But in practice, actually building effective documentation for something other than a trivial function like this can take a bit of time. But if you've got multiple arguments, if you have something we should say here is we should tell what the default behavior is, for example. In this case, that would be very complex. Building out your documentation so it's as clear as possible takes time. And so actually you don't come back to the console as often as you might think. The other thing is that literally, even though this text and this text are nominally the same thing, because this is so much easier to read, things that you thought were sensible on the left end up being complex on the right. And so this interaction between the unrendered and rendered versions is actually really useful for getting your documentation right. And so it looks inefficient, but to loop through this process of hitting document load all, check your help, is something that I end up doing a lot of. So yeah, where was I going? So it slows you down to do better help. It slows you down to do more useful tests. So when I started writing packages, and still if I'm just doing something for me and I'm in a hurry, particularly for proof of concept, if I don't know if a function is possible or can work, I won't do this stuff. I'll literally just write some functions, load them, and see if it runs. The benefit of documentation and testing is that it makes your future life easier, as well as your users. And so I'm in favor of it these days for that purpose, and particularly for packages you do intend to be more widely used. I think it's very the case is very easily made that that's an important function. So testing, I'm going to move on to that. Again, feel free to jump in with more questions if you've got them about the stuff we've done so far. And I can go back and show more stuff about functions if people are interested, how to, but in effect, the details have been covered there. There was one thing if I've got time, I'll come back and talk about how you deprecate functions, but that's not a generic use case. So look, in terms of how to build tests, once again, I'm going to rely very strongly on prepackaged solutions to this. So there's a package called testthat. Which unsurprisingly builds and runs tests. And as a very simple function, actually, I think the function I'm about to use is within use this. So let me load that. It got loaded with DevTools, but I'll load it again anyway. So the function I'm going to start with is called use test. Yeah. So basically, rather than me say, oh, you need a file with this name, and within that you need a file with this name, and so on, because that file structure is really important for R to be able to find all the stuff that it needs. Use this as simply just, so I'm typing in all place. No, I don't want that. Just does that work for you. So in this case, I'm literally going to just say the name of the resulting file that I want. The function that we're going to test relates to background colors. So I'm just going to say it should be called background. Best way to see what that did, I mean, it gave me a description, which is lovely. You'll now notice there's a new folder. It's called tests. We don't need to worry about what this R script does at the moment. Within that, there's a folder called testthat. And this folder, this file here, just has some boilerplate text in it to show you roughly what it should look like. When you have, so there was a question earlier on about naming files and how we group functions together into files. My practice for tests is that if you've got a .r file in your that contains functions you're using, you should have a corresponding test script. So that there should be basically the same number of scripts in your R folder and your testthat folder. And my reasoning there is that if you've written a function, you should write a test for it within reason. And basically, this gives an example, but just to walk through this, what this consists of is always has the same first nine characters, which are testthat, unsurprising. The first thing that you give is a bit of text that is a note to yourself. Almost no one else will see this, Cran might if they run it, but it says what it is that you're trying to achieve, because it's not always clear from looking at code what it is that code is supposed to do. For a function, you write your documentation that tells you. For a test, you just write this single string. And so we might say something like, we don't need to write testthat. Let's think. Background color changes when we tell it to, right? So now our job is to write a piece of code that evaluates whether that is true. This requires a little bit of creative thought. And actually working out what are sensible tests requires some thought. Usually it's the set of things that you want your user to be able to do, and you want your package to be able to deliver to them. You write a test that replicates that behavior. In this case, most of the time when I write functions, they're like manipulating data frames, or there's actually a result from it that you can test. ggplot is, to state the obvious, all the functions do return something, but their main purpose is the side effect that they generate a plot. So if we were, it's very difficult to just say ggplot, MT cars again, and then run a test on that, because you've produced a plot, we haven't produced any objects to work off. So what I'm actually going to do, I'm going to take our example from earlier on. I'm just copying this from a separate script. So that is, I think, the example we used earlier on. I'm going to delete this example because it's distracting me. And this last, I'm just going to check that actually works for us here. Okay, that's the example we had before. Like I say, it's difficult to test that. So what we're going to do is we're going to output it to an object, which we're calling P. Now, if you run P, all you do is you get the plot again. But if you look at it, you actually get a really complex object. So this is huge, but I don't know if anyone's ever tried doing this, but ggplot2 objects are very information rich. They store the data that's plotted on it. They store all the aesthetics. Yeah, there's the data set. In fact, look, that's the whole data set. I guess that makes sense, right? Because we have provided the whole data set, but not just the aesthetics that we asked it to draw, for example. So in practice, if you've got people's ggplot2 objects, you can extract raw data from them rather than just what was drawn. That's really quite neat. So in this case, again, this is fairly cumbersome, and normally I wouldn't do it this way, but we can use this. So what I've used is strs to find the structure of the data that's in there. And the thing that background color changes is that the background is red. And if we scroll down, we don't need stat scales. No, it's not that. Theme. So there's a theme parameter there, and then panel background, and then it says the fill is red, right? So about 5 layers down in there, there's an object, and we can literally just map this using the $sign. So as though, well, because it's a list, right? So we can go down this list, or down the nests of this list, I guess, until we get to the bit that we've changed, which is that, and that should be red if we've worked. So now we need to tell R that red is the correct answer. So there's a set of functions, all beginning with expect. In this case, I'm going to use expect equal, which we might use quite a lot. So, and we tell it the thing to look at, which in this case is this aesthetic here. And then we tell it what we expect it to be.
Martin, just a question, and this one's a question from me. Wouldn't that break on days or dates containing a 3?
Yeah, it would. It would, yeah. And yes, when I wrote the tutorial, I didn't think I'd do that quite bizarre nested function inside it. So in practice, what you'd have to do, oh gosh, you could do a few things. Let's not keep that. That's what you'd do if it didn't have that unusual behavior. You could do now let's think, what would be a better solution? If we rerun this without background color, what's the default background? So we can find that by just going to that same location and seeing what the basic is. Null. So I think there might be an expect null. Yeah, right. No, you know what? That wouldn't work because we want it not to be null, right? So what I guess, sorry, this is my internal monologue going on here. I'll try and explain a little more clearly what I'm doing. If we don't use background color or background color fails, the value that we test comes back as null. So we need to test that it's not null. So we might use one of the expect functions that evaluates logicals. So there's expect underscore true, expect underscore false. So we might say expect false is dot null. And then the name of that, oh, not that one, this one. So at the moment, that errors because it is null. But if we put our background color in that value is now red. And so you notice now that I ran that bit of code saying expect false, and it didn't do anything. It went straight past it. And that's expected behavior when your tests pass. Does that make sense?
Yeah, bro. Thanks, Martin.
Yeah. And as that example might show, there is no right or wrong way to write a test. So this is in many ways a simple function. You're right though. The fact that another way to do it, I guess it's possible that you could get an error where background color generated the wrong color, but still not a null, right? Like there's loads of ways that could happen. Maybe. There is the way I write code. So you could do it something like, is there expect any? No, what you'd say is you'd expect true, and then you take this thing. I'm trying to think of the safest possible test you could write here. And I always get my in things the wrong way around. So we know that it could only be yellow or red. Yeah, okay, whatever. So does that work? Yeah, it does. So we could do expect true that it's one of those. That would work too. And that's a little safer than the null one because null is pretty uninformative. So yeah, there's loads of different possible tests that would effectively test the same thing. And this is where you'll get caught out long term, right? Is that there'll be some really odd edge case where someone manages to make your code break in such a way that it makes your background black and you didn't test for black because you've never thought of it. But it slips past your tests because they're only tested designed to look for yellow or red or something. So no tests can be perfect or complete for any remotely realistic or complex function, but they're a good start and they encode what you expect to happen, which is a really useful purpose as well. So this here is, it is a test. It is checking you haven't made a mistake, but it also is a statement to yourself that this is what your function should do. In the same way of the documentation is a description of how it should behave. And so, as I mentioned earlier on, thinking really hard about how a package should behave, this is part of that process. And it does slow things down. It does force you to think really hard. It also, it means that if you change your decisions about how things should behave, it makes it harder to pivot your package to behave in different ways. But once it's there, it sort of freezes it a little. So it makes it harder. It makes it more robust in that new format. I'm not sure that freezing metaphor works, but never mind. So look, I won't spend a whole lot more time writing the same tests over and over, but that's the principle there. So basically, you could do an endless number of these. You can just use expect functions and call code within it that does manipulation. But my general approach is to generate an output that's been manipulated by your function in some way, and then quiz the behavior of that using the expect functions. And as long as it's all within these curly brackets, then that's a piece of code that can run. And then, of course, if you have a second test you want to do, you just put it here. I don't even know what that would be. So save that. Now, I guess the obvious point is that we've checked that to make sure it works in the console. Seems to, pretty happy with that. Then the obvious thing is how you get to run. And once again, there's one of these lovely short commands from DevTools. You run test, it works, you're fine. I think there's something like 200 or 300 tests in the package I worked on recently, and the more complex the set of transformations those tests have to do to run their checks, and the more of them there are, the longer it takes. So expect that to run for minutes if you're doing something more complex. But what you do see is that this is actually really nicely formatted output. It tells you which package you're working on. It's got this little table style format where, so fail, warn. Does that one stop? No, that's fail. I forget. Skip, it says at the bottom, silly me. And pass is represented by an OK. You'll get one row per file. So if we were to write more tests within test-background.r, this number would go up. So if we'd written 10 tests, you could plot the sum of that row would be 10. Hopefully that'll all be okay, but some might fail or warn. And then for the next file, you'd get another row and so on and so forth. So that's the summary. And this is the outcome. If any of these had failed, you would get a detailed description. So we can test that by just changing this. So we know that this doesn't return black or purple. But if we run that test, you notice now, not only do we have that something failed, where it failed, not just what file it failed in, but which line of it failed, which is enormously useful. And this text that we wrote at the top that gives the detail about specifically what we're trying to check gets printed here too, as well as the specific expectation that was failed. So it's really detailed. And while it's devastating when you get dozens of these, because you think you're being really clever and you think you've nearly finished a package and then you get errors, this is the level of information that you want to be able to fix that bug. It can be very useful for fixing errors that you've encountered. So that's test. The last thing that I want to raise is a different kind of testing, which is default testing called the Rcmd Check. I recently forgot this existed before trying to release a package, and remembered with about, expecting to submit my package to CRAN, and then went, oh, hang on, isn't there a check function? And had just another 3 days work fixing all those tests. So it is worth remembering that that these two things exist. Like I say, we've looked at test. Test is the things you write yourself to tell yourself and the user how the function should behave. Check is the stuff that CRAN writes for you and says, no, your package has to behave in this way or it's no use to anyone. Again, it's written in the dev tools, and we'll see what we get. You can see this is a little bit more low level. Like there's a lot of checks. Some of them are written in languages that can be a little bit confusing if you're not familiar with it. And you get a slightly different output at the end. The important point being here that these should all be 0 if you want to submit to CRAN, for example, or really just to help your users out. And the warning we got here is that we haven't given a license. So that's not particularly helpful, but would be in description. Oh, there we go, just there. I'm just going to type that. Actually, that might even work. So you notice that there was something that just came up there saying checking package dependencies. So we'll check that that when you've used a function from somewhere else, that it knows where to find that function. So we had a chat earlier on about that. Need a license file. You see, so this is the sort of thing that you get a lot. Is you think you fix something and then you get a slightly different error. The same is true with test. Getting through these, but you notice though that these are in decreasing order of severity. Errors are worse than warnings, which are worse than notes. And before we had a warning and now we've got a note. So that is an improvement. It's just that we need to have different information. So I'm just seeing someone, I had an error because I didn't put depends ggplot. Yeah, that would happen. So I didn't really focus on that. So I might be leading some of you down the garden path a little bit with this. So I think that's just to go through them all then, the major functions that we've used today. Actually, we didn't use build, but we could have done that. Document for building our documentation.
So someone in the chat's just pointed out that they had an error because they didn't put depends ggplot ggplot2. So I think that's important to highlight. I think that you make sure your depends and suggests are all up to date. Yes,
absolutely. So yeah, depends is what might not be clear, I guess. When we hit document, it writes, and actually we just did it so we can see, it writes to the namespace. So in our case, this gets a little, the challenge that I have with package development is there's a lot of moving parts, lots of files, they have to be in specific places, you edit something, it affects something else. And that makes it a little hard to follow, but just to walk through the logic here. No, that's the test file, we've done with that for now. We told, for a start, we used some ggplot2 functions. We decided that's how our function should work, is to call on ggplot2. Then we told it to import from ggplot2 those functions that we used. And then we ran document, and that put them in the namespace. None of that interacted with description at all. And so it's quite possible to have a really well-documented package if you haven't added that one piece of text. It doesn't even know ggplot2 exists. And I think, look, I didn't develop any of these like really useful packages that we're depending on here. But I think it's because so much of the description is often manually written. You know, you have to write your description yourself. You have to write your title. The format for authors is actually fairly complex. So, for example, like if I was to put, so often we replace a simple author tag with some code called authors at R to let know it's R code, and we literally write in using the person class, you know, my name is this, my email is this, your role, and there's like a dozen, well, it's like loads and loads of possible roles, for example. So anyway, the point being, not that that matters particularly, and you can add many authors and stuff. The important point is that there's no markdown version of this. This is the only thing you edit. And so I think the reason that DevTools doesn't update it would be fairly trivial for it to say, make sure that anything that's getting imported from goes in depends, but it doesn't. And I think that's the reason, is because it doesn't want to mistakenly overwrite something you've done yourself. Someone can tell me if I'm wrong about that. What is interesting though, I didn't write this and it wasn't here before. So clearly there are, and you notice it not only says it needs test that, but it also says what version of test that it needs. You remember me saying before that suggests is for things that your package needs to run or to build, even if the functions themselves don't use it, and test that matches that. So because cran runs test that, you have to have it suggested. But that's been added. I'm not sure at what point. I'm not sure test that does it. Maybe it came out of test that when we said use test. Yeah, I suspect that's what's happened actually. So, sorry, I'm literally just thinking about this for the first time. I think use test has generated that. So let's have a look at the description. That doesn't actually tell us much. But yeah, I suspect when it sets up the same thing, the file structure we used, for example. So you remember that it created this file. I think it's probably imported that bit of script at the same time. But
if use underscore test is part of the use this package, then that does tend to have functions that automatically update your description file for you. So
yeah, right. It's funny, isn't it? So you tend to do this stuff once. You build a package, like you establish a package once, you set up your tests once, and then after that, everything is just adding in new content. And And so actually what it does the first time is behavior you see very rarely. So I didn't actually think about that until now, but maybe that's what's affecting it there. But thanks, Chris. Yeah, that's really useful. I hadn't thought of it. Righto. So look, we're at 8:30. My time. Power's come back on, so I'm glad about that. I might just pause just in case people do have some questions. There's a little bit more stuff I can talk about, but that is the core information that I want to cover about packages and package development. So does anyone have questions they want to contribute to the chat, or feel free to speak up? I don't mind talking if people would rather.
We've not had any extras yet, and I've not seen any on Twitter, but just wanted to give a bit of a shout out to one of the replies on Twitter from Matthew Granger. Answers the question about the difference between depends, imports, and suggests. It's a quite helpful link. So I don't know, maybe Neil could add that to the YouTube description as well.
Yeah, lovely. Yeah, no, Matt knows what he's talking about. People should listen to him on many topics. Lovely. Okay, no, that is helpful. Thanks, Chris. So, in which case, we don't have to stay the whole 2 hours necessarily, but there are a few more things that could potentially be useful. Something there's two topics in particular. One of which is deprecating functions. So this isn't something that will be an issue while you're first developing a package, but something that we've found, particularly with packages where the syntax is experimental, although where there are many possible ways to do something and you might want to give people different options, it can emerge that you want to retire one way of doing something. So if, for example, we decided that from now on, we wanted to create a function that was just called background. And we wanted it to have more options. So a classic example is that a lot of the ggplot2 things have a color and a fill option, right? It's really trivial to amend our earlier function to do that. So let's have a think. Maybe if now our default is that the edge border is red and the fill is yellow. And actually now previously we had to literally enter this stuff in the console, but now we know that we can do, well, we can save that file, we can load all, and we can rerun our code from earlier on. So now we have fewer characters. Yeah, okay. So, I mean, it's a little misleading because it's only the background rectangle that we've changed. And so it's the edges that are red, not all the grid lines. We could change that by, going into theme and setting all the grid lines to be red as well, but we don't need to for this illustrative case. But let's assume that that's so useful to us and we so prefer the language background rather than background color that we're going to retire background color. So maintaining two functions, you can, you've written them both already, so that's one option. But an alternative is then to literally say, actually, we're going to keep background as being the function that does all our work from now on. And everything that we're going to retire, we're going to make into a shell that just calls our core functions. And so a way that you could do that then is you would say, background color, rather than having its own functionality inside it, you then have to maintain and check and run tests on and all that sort of stuff, is you keep the arguments the same, but you just run that through background. Now you notice though that background and background color are not synonyms because previously the aesthetic it changed was fill, and now color maps to the edge line, not to the fill. And so in practice, to get this to work, you'd have to correct your defaults to match your historic behavior, not your current behavior. So previously, I think that was fill equals red, and I don't know, color was black or something like that. Something like that. And you notice now that there's nothing going on inside this function except it's calling the newer one. So if we, again, run our whole like cycle again, load all. So that is, I mean, we didn't have a gray edge, I don't really remember, but that's the default that our previous users would be expecting. It's the same syntax they were using, but we've effectively gutted the function so we don't have to run tests on it. And now we can reassign all our effort to making sure that background works, which is the newer and more flexible function. And in practice, what you probably do, I'm not going to do this now necessarily. Why not? Is you'd say something like, we're not going to use this after version 1.1.1 or whatever. Some sort of message like that to suggest that. Oh, it stopped it working somehow. Interesting. Okay, that shows unexpected behavior. Maybe because I put a message in that broke it. I don't know what happened there. All right, I'm not going to look into it in too much detail because that's perhaps quite a rare use case, but it is, but that principle of maintaining previous behavior while moving on to a new syntax and functionality.
Sorry, Martin, just having deprecated a function before, there is a dot deprecated function that you kind of wrap it in, but it's probably a bit too complicated. Bit too much to explain sometimes, but there's a manual documentation that explains it.
Yeah, lovely. Yeah, here's a confession for you. We've done it a bit lately, but someone else in my team handled it. And they did an amazing job, and the deprecation messages are lovely, but I can't remember how it was done. So yeah, there's some ignorance for you. The last thing that I'm going to raise, and because it's come up for me a little bit, I don't know how universal it is, but it's putting data into a package. So, I mean, this is fairly, it's a simple piece of code, but it is quite useful to have. So I'm just going to give an example where, let's imagine we wanted to generate some data. Oh, and this could be anything. So that's what, let's see what we've just created. Nothing very interesting, right? Just some information, but let's assume that that's a stand-in for some critical piece of data that your package needs. Obviously, the most efficient way to store that in R is with a .rds file, and there's a built-in way to do that. Again, it's within use this. So this it's quite straightforward actually to just go use data, a data set in this case. And then the last thing we'll do is go internal equals true. And the benefit of that, and it tells you what it's done, is that within our R folder now that data exists. It's always called the same thing, sysdata.rda. Doesn't matter where you store it, it ends up getting called that. And what's amazingly useful about this is that now if we go remove a, oh man. And then load all, we can call a data set at any time. So someone asked a question earlier on about Shiny apps. This is a case, that's a case where I've used this before. Sysdata can be anything. So I've used it to store like UI information for a Shiny app, for example. It doesn't have to be just data. There are some big packages that are all about data. In fact, I think Wolfgang was talking about metadata. I think that has a similar structure built in which case, yeah, it's very efficient, very small, shares a lot of information very quickly, and it recalls it very fast too. So always useful to remember that you can store data as well as functions within this R folder. That said, they do have to be just one RDA file. You can't have sysdata2.rda, for example. So it's usually, if you have lots and lots of data, then usually you need to put some thought into how that needs to be stored. I find that lists are your friend there. If you've got, you can have many different kinds of objects within slots of a list and just store it to this RDA. It does mean you need to index things quite carefully, but it does work. Right, that's literally all the stuff I'd written code for. I guess the last few things that I want to flag are sort of warnings or points that I've noticed about development, and it's a little bit hard to know how much detail to go into here. But what I might do is I might share some examples from some stuff that I've done that isn't in RStudio. Hang on. Right, I'm just going to share my browser. So first thing I want to talk about is naming. So this is the help file for a package that I've been working on a lot lately. It's called Galar. It doesn't matter especially what it's for. It gets data off the internet basically about biodiversity, but that's fine. The important point here is that we put a lot of work into our function naming. And that's not something that's easy to go into in a workshop like this, where you're trying to show someone line by line how you build things, because it gets too big too fast. But basically, we made a decision that this package was going to do a lot of things, and therefore it needed a careful naming convention for people to be able to remember what to do. And so we basically have 3 types of function now. The whole purpose of the package is to download data. Anything that downloads data has an atlas prefix, and then the name of the type of thing that it downloads afterwards. Occurrences are a type of data, counts are the numbers of them. You can modify what kind of data you get using a function that begins with the Galar prefix, which is just chosen because it's the name of the package and people should remember it. In this case, the suffixes are the same as for major dplyr functions, and they work in the same way, with some exceptions, because there isn't a geospatial element to dplyr yet, I don't think. And then there's a bunch of things that search or look up information. And so the point of this is not to say that this is the best syntax in the world, because for a start, we had a different one a month ago and we changed it because we thought we could do better. So I'm certainly not going to argue that we've got everything right yet. But helping your user by having names that, for a start, every function is in the same case. It's all lowercase with underscores, so they never have to think about how to type it, and that's classic tidyverse, of course. There's only a certain number of prefixes. That narrows down the complexity, and the prefix tells you something about how the function works and what it does. You could come up with different rules for different packages. There are different programming paradigms that, like, this wouldn't work very well if you were using R6, I suspect. It's a guess. I'm not very good at R6. But helping your user as much as possible with your naming conventions is a good principle, and it's very difficult to do well. So we've done our best there. The other point that is useful to raise, and it's one that comes up on Twitter quite a bit, is about dependencies. So this is another package that I've written, incidentally, that has no tests in it, so needs an update. So it violates my own rules that I've described to you today. This RevTools is, I think was kind of neat when I released it. I think it's still pretty good. It needs a little bit of a polish, but it still does what it says on the tin, which is to visualize patterns in text, enable you to select points based on their similarity. To do that, it has Shiny apps built in. You'll see here Shiny and Shiny Dashboard. It has text mining, Snowball C, Ngram. It's got the Plotly visualization library. And it's got some statistical manipulation tools. AD4 is an ecological modeling package. It may be clear from that those packages don't have much to do with one another and therefore have their own dependency trees that are fairly large independently, never mind when you glue them together. And in practice, when you actually install this, it's something like 100 packages. Now, that I feel was critical when I built it. There's new packages that have smaller dependency trees that I'm shifting this to and will put on CRAN as soon as I'm able. Some would say that there's two counter arguments. One is that R is pretty stable. People are good at maintaining things. If you pick packages you trust, dependency trees aren't a problem. The other point is that that's a lot of downloads. Some people are on slow internet connections. Some people don't have fast processors. This thing does take time and it's annoying and it restricts people's access to your packages. Plus, it's possible a package will break and then they can't download it. And this has happened. So I think topic models, that package that I use as a modeling framework in here, breaks on some operating systems and they can't use RevTools. It's not entirely common, happens to the best of us, but it does happen. So, look, you notice that this is in imports, not depends. That's the difference, isn't it? We use depends for R and imports for everything else. I don't know if that's the correct answer, but Matt does. Go ask him. So, sorry, I got distracted there. Point is, you're going to have to think about dependencies once you get into any package that does any large amount of stuff. What conclusion you draw is up to you. We've got a real problem with that at the moment in a specific case with a package called Biomod2, which is actually a really useful package that I'd encourage you to check out and is actually under active development. They're doing cool work with it at the moment, but we're using it purely for a backend modeling solution. And you'll notice it includes things like, well, for a start, it's built on raster, which is going to be out of date soon, but it's also uses ggplot2, it uses rasterviz, which are entirely different modeling visualization frameworks for a start. It also, until recently, I thought it used Shiny, and it seems they've dropped it, so that'll make our life a lot easier. The point being that packages that do everything can be difficult to depend on because they bring their own enormous dependency tree. So if someone were to do some analysis that would build on RevTools, the better solution would be to say, actually, what is it, the element of RevTools that I want to replicate, and go to the underlying package that actually does all the work rather than import it through RevTools. And we're thinking there's an open question whether we do the same thing with Biomod2. So those are big questions, but ones that you might find. And the last point I'm going to raise before I stop talking, because this is, obviously this is supposed to be a workshop, and I realize that I'm not giving you exercises or things you can do to code. I'm just speaking now, but nonetheless, it's easier. Is a concept of, it's about non-standard evaluation. So this is the idea that that you can put in unquoted text like you can in tidyverse functions. If you're using dplyr, for example, you can quote column names without putting them in quotes. I'm going to stop sharing my screen because it's not important anymore. That is really intuitive code to write as a user once the package is built. It's very difficult to write as a developer, is my perspective on that. And it requires quite a lot of care in processing objects in some ways that are not entirely straightforward. And so if you're thinking of using NSE, I'd suggest just using depending very heavily on packages that already do it and just passing functions straight to them. So, depend on dplyr and all that sort of stuff. Don't try and rewrite it yourself. So that's all the content that I had to cover. I realize we're coming at 15 minutes under time, which I hope is acceptable to people. But we do have some time. So if people do have further questions, please feel free to jump in.
I've had a thank you that it's been extremely useful.
Good to know. Yeah, thanks. It is hard to know exactly what with such an open audience what to present. It's difficult.
No, I've certainly found it valuable. I fell into developing some packages, and I think there are some things that I've definitely picked up from that is very useful moving forwards.
It's funny. It's what I find is that everyone I speak to is even remotely engaged with this sort of process has a slightly different workflow, slightly different tips or tricks. Yeah, I always learn things from doing this myself. So I'm glad that that's been reciprocally useful.
I suppose I have to ask, and this is partly from my point of view, but I know you used RStudio for this, but you said you use a different development environment, and I suppose we do, certainly in this conference, we focus quite heavily on the use of RStudio for a lot of audience members, but it would be, I guess, valuable to hear what other workflows and other tools exist that people use.
Oh, sure. Yeah, look, I mean, I don't know. So RStudio is nice. It's an aesthetic thing, right? Like functionally, I can't criticize it. It doesn't work very smoothly on my work computer, and that's caused me some you reset the theme and it breaks. So what I use is I just use a text-based like a text editor called Atom.
Oh, right, yeah.
And actually, yeah, it's produced by GitHub. Yeah. It was cool a while ago and isn't anymore, but it integrates well with GitHub. Unsurprisingly, it shows you which files have been edited, shows you your file structure very clearly, and otherwise just gets out of your way. So that's my solution. And then literally you can port that to the R console that you download from CRAN. And so in effect, it ends up looking like RStudio because you've got your script in the console.
So I personally use Visual Studio Code, which is probably a similar-ish workflow, but I just think it is valuable to hear what other people use for their development.
Yeah, look, and there are equally good and better solutions than mine. It's just you tend to. I remember a few years ago doing a bit of looking around and settling on that, and it works. Yeah. There are reasons for and against.
I'm definitely the same with VS Code. I used it for developing in other languages, and then tried using RStudio, and it just was unfamiliar to me, so I didn't want to learn something new. We have had some more questions that have come in. So one from Claudia, who says, what tutorials or courses would you suggest to get a more comprehensive idea? And a similar question from Constantine, or Eve saying, what would be your recommendations for going further?
Yeah, so look, the obvious answer there is the book by Hadley Wickham, sorry, wrong Hadley. Yeah, literally just called R Packages. I think you can Google R Packages book and it will come up. And look, that picking up even a digital version of a book is a bit confronting and a bit scary, but I found it easy to read. I can go to the bits that I need information on and it tells me very clearly what I need to know. Yeah, and it's free. So I've found that really useful.
I'll pop it in the Zoom chat link, and maybe again Neil can add it to the YouTube description.
Yeah, lovely. So recommendation for going further, I guess I'd interpret that the same way. It's like if you're looking at package development. Yeah, other than that, I mean that I guess there's a broader point there, which is that all the tools that I've talked about today weren't around when I started. And actually, RStudio didn't exist when I started. And the development team there, I mean, I know that lots of people have said this, but the tools are just outstanding. And there was a bit of a kerfuffle a few months back when it looked like CRAN were going to archive one of their packages, and the response seemed to be like, of course we were going to fix it. Like, we have a bunch of people who know what they're doing and they work on it all the time. And to get that sort of support in an open source software ecosystem is, I mean, kind of unbelievable, right? I was talking recently with a new colleague who works in Python, and of course there's always an argument about R and Python being better, but I said, look, I'd love to learn Python. I find there's a lot that's interesting about it. I've used it before. It's harder to install, and that stops me. And that might sound really pathetic to a lot of people, but the sort of the sort of benefits you get from, for a start, having had CRAN be stable and then having the RStudio team developing new content that's really useful at all time. The combination of the two is so powerful. And we're really fortunate to be able to have those resources. And so I'd recommend any of their, like, all their documentation is good, their websites, their ebooks, all of it. Anytime I've got a question, I go there.
I think from my point of view, get stuck in. I find the easiest way to learn how to get better at developing stuff is perhaps maybe not start with creating your own package from scratch, because that's quite daunting. But now that you've got the basics of what things look like and what a package looks like, find something you rely on and you use and think, how would I use this better? Is there something this doesn't quite do that I want it to do? Can I make it do that? And then, that can be a really valuable way of kind of getting that experience and going, yeah, you know what? This is only a small change, but actually it's going to make life better for everyone. So I'll do that, and I'll go watch the tutorial on how to use Git and GitHub, and do that workshop and submit a pull request, and you'll find yourself, in a position to help.
Oh, I'd completely agree. And actually, look, I've talked a bit about CRAN today and passing tests and checks and all that sort of stuff. And that's useful. You don't start there. I didn't. I suspect you didn't, Chris. Like, it just, for me, it was, I needed to do something a lot, like the same actions over and over for different people at different times. And putting in a package just saved me having to copy and paste code. And that's enough, and you could, putting on your GitHub is a good idea because it's a bit more stable than if your hard drive crashes, you don't lose it. So you can start there, and you very quickly like fall into good practices these days. There's a lot of things that support you to do things well. It's really quite encouraging.
Yeah, for me, it was, I wanted to draw a Prisma diagram, and the Prisma 2020 package existed, and I fixed a couple of bugs, and that's what it takes, is you just kind of find something you like and go, oh, actually, it doesn't quite do this right. And then you fix it.
Yeah. Someone did that this week for Galar, the package that I maintain most actively at the moment. And it was amazingly useful. Like, they'd spotted a bug I just wouldn't have found. So people, and it might not be clear to beginners, just that might appear cheeky or a strange thing to do, but to the developer, it's not. It's like, someone's used your package, they're engaged enough that they wanted to like look at your source code. It's actually really gratifying. So it's the opposite response that you might expect as a newcomer.
Oh, I don't think we've had any more questions. I'll just double check on Twitter just in case, and on YouTube. I don't think we have, because Neil's been pretty good at keeping an eye on. I don't have the YouTube video on here. Here we go. Right. Yeah, we don't have any. Oh, hang on. We've got just a quick. Can one make if commands in the expect equal function? That was just a question that came up on YouTube.
In the expect equal function.
So
yeah, I guess so. I haven't tried it.
I think
while you're thinking about that, there's a question from Matt Granger, which is really serious and really needs to be addressed as soon as possible. What bird's on your shirt?
Flamingos.
Nice.
Yeah. Sorry, I can lean in a bit more closely if you like. Originally, this shirt was white and it went through the wash with some jeans, so it's a bit blue now. There you go, Matt.
Excellent.
Matt says,
I like to sprinkle these details in just for the detailed observers.
But yeah, if commands in the expect equal, I would suspect so, because you can pass any function to the expect equals function, right? So therefore you can. You could do. That's a good point, actually. You could have if and then nest different expect functions within else. It would work, I think. Cool. Thanks very much. Right, so I think we are done. If no one else has any more questions, I guess all that remains is to say thank you to Martin for his time today and valuable expertise, and thanks to everyone who joined us on live on Zoom, but also quite clear that people were engaging through YouTube and Twitter, because there were the odd question came up through that. So it's really nice to see.
Yeah, thanks everyone. Thanks to the conference organisers. You guys have done a great job. Hope you enjoy the rest of the conference.